Right now, as you watch this, a river wider than the entire Amazon, flowing not through jungle but through the deep dark Atlantic Ocean, is slowing down. And if it stops, Europe freezes. Not in 1,000 years. Potentially within your lifetime. Welcome to the most underrated, most powerful, most terrifying force on this planet, ocean currents. The invisible engines that decide whether your city gets snow or sunshine, whether crops grow or fail, whether coastlines flood or stay dry. And almost nobody is talking about how close we are to breaking them. Let's change that. 8 facts. Each one more shocking than the last. Let's go. Fact number 1. A single ocean current carries more water than every river on Earth, combined, times 100. Let that number sit for a second. 100 times. Not 100% more. 100 times more. The Antarctic Circumpolar Current, the powerful ring of water that flows continuously around Antarctica, moves approximately 173 million cubic meters of water every single second. To put that in perspective, the Amazon River, the largest river on Earth by volume, moves about 209,000 cubic meters per second. That means the Antarctic Circumpolar Current is moving roughly 830 times the volume of the Amazon every second. And when you add up all the rivers on Earth combined, the Antarctic Circumpolar Current still dwarfs them by a factor of close to 100. This is not a river. This is not even a current in the way most people imagine it, a gentle drift of water. This is a planetary-scale hydraulic system, a churning wall of ocean that connects the Atlantic, Pacific, and Indian Oceans all at once. It's the reason the Southern Ocean exists as a distinct entity. It's the reason nutrients from the deep ocean get pulled to the surface near Antarctica, feeding entire food webs that ultimately keep oxygen levels stable for the whole planet. Visual note: show an animated blue ring around Antarctica pulsing outward, with a bar chart comparing river volumes, all rivers stacked on one side, the Antarctic Circumpolar Current dwarfing them on the other. Use ocean blue and ice white color swatches. And here's the kicker: this current has been flowing for about 34 million years, since Antarctica separated from South America and created the Drake Passage. It is older than the Himalayas. And we've only been seriously studying it since the mid-20th century. Fact number 2. The ocean has a global conveyor belt, and it takes 1,000 years to complete one loop. Scientists call it the thermohaline circulation. Thermo, meaning heat. Haline, meaning salt. It's the planet's deep ocean circulation system, and it works like the world's slowest, most consequential conveyor belt. Here's how it works, and pay attention because this is genuinely incredible. In the North Atlantic, near Greenland and Iceland, surface water gets cold and salty, saltier because fresh water has evaporated from it, leaving the salt behind. Cold, salty water is dense. Dense water sinks. And when it sinks, it pulls warm surface water northward from the tropics to replace it. That warm surface water is what gives Western Europe its shockingly mild climate. London, England sits at the same latitude as Calgary, Canada. Calgary gets winters that regularly hit -20 degrees Celsius. London rarely drops below zero. The reason is not geography. The reason is the Gulf Stream and the thermohaline circulation pumping tropical heat across the Atlantic like a central heating system for an entire continent. Visual note: display a world map infographic with a slow-moving animated loop, red arrows for warm surface currents, blue arrows for cold deep water return flows, circling through all major ocean basins. Annotate latitude lines comparing European and North American cities. Now here's the part that should make you stop and stare at the ceiling. This entire loop, from the North Atlantic, down to the deep Southern Ocean, across to the Pacific, back through the Indian Ocean, and up again, takes approximately 1,000 years to complete. The water that is sinking right now near Greenland won't resurface in the Pacific until around the year 3025. It is literally carrying heat and carbon from our civilization into a future we will never see. Fact number 3. The Gulf Stream is slowing down, and scientists say it's at its weakest point in 1,600 years. This is where the story gets urgent, and the science gets genuinely alarming. In 2021, a landmark study published in the journal Nature Geoscience analyzed ocean sediment cores, tree ring data, and coral records going back 1,600 years. Their conclusion: the Atlantic Meridional Overturning Circulation, the AMOC, which includes the Gulf Stream, is now weaker than at any point in that entire record. Not slightly weaker. Measurably, significantly weaker. And the suspected cause is exactly what you'd expect: fresh water from melting Greenland ice pouring into the North Atlantic, diluting the saltiness of the water, reducing its density, and undermining the sinking mechanism that drives the whole system. Remember fact number 2, the conveyor belt runs on cold, salty water sinking. Add fresh water from a melting ice sheet, and you're essentially jamming a wrench into the gears of the world's climate engine. Visual note: show a timeline infographic from 400 AD to present day, with a color gradient line graph illustrating AMOC strength declining sharply in the post-industrial era. Overlay a melting ice sheet diagram with freshwater runoff arrows pointing into the North Atlantic. A 2022 study went further, using statistical modeling to suggest the AMOC could collapse, not just weaken, but fully collapse, between 2025 and 2095 under continued warming scenarios. If it does collapse, climate models project that average temperatures in northwestern Europe could drop by 5 to 15 degrees Celsius within just decades. Not centuries. Decades. That's not a slow climate shift. That's a civilization-altering event happening faster than most infrastructure can adapt. Fact number 4, there is a current so deep it flows 4,000 meters below the surface, and it moves faster than you'd expect. Most people imagine deep ocean water as still and silent, a cold, dark abyss where nothing moves. The reality is almost the opposite. At depths of 3,500 to 4,500 meters, that's nearly 3 miles below the ocean surface, there are powerful bottom currents called contour currents and Antarctic bottom water flows that move at speeds of up to 1 meter per second in certain locations. Now, 1 meter per second doesn't sound fast. But at 3 miles deep, in a pitch-black environment under crushing pressure, that is extraordinary. These deep flows are strong enough to sculpt the seafloor itself, carving channels, moving sediment, and creating underwater geological features called contourites that stretch for hundreds of kilometers. The densest of all ocean water, Antarctic bottom water, forms near the coast of Antarctica when sea ice forms and expels salt into the surrounding water, making it so dense it sinks all the way to the bottom of the ocean, literally the deepest layer of the global ocean system, and then flows northward into every ocean basin on the planet. Visual note: use a cross-sectional ocean depth diagram with color-coded density layers, lightest water in sky blue at the surface, deepening through navy to near black at the bottom. Animated arrows show Antarctic bottom water creeping northward along the ocean floor. Here's what makes this fact jaw-dropping: this Antarctic bottom water takes oxygen from the surface all the way down to the deepest ocean floor, making deep-sea life possible. Without it, the deep ocean would become anoxic, completely depleted of oxygen, and the entire deep-sea ecosystem, which we've barely even explored, would collapse. And warming ocean temperatures are already making this bottom water less dense, less likely to sink, and less effective at oxygenating the deep ocean. A 2023 study published in Nature Climate Change found that Antarctic bottom water formation has declined by about 30% since the 1990s. 30%. In 30 years. Fact number 5, El Niño and La Niña are basically the ocean's heartbeat, and they can trigger famines on 4 continents simultaneously. You've heard the names. El Niño. La Niña. You probably associate them with weird weather patterns, maybe extra rainfall or drought somewhere you don't live. The actual scale of what these ocean current shifts do to human civilization is something most people have genuinely never been told. El Niño occurs when trade winds in the Pacific, the steady east to west winds near the equator, weaken or reverse. Normally these winds push warm surface water westward toward Australia and Asia. When they weaken, that warm water sloshes back eastward toward South America, raising sea surface temperatures in the central and eastern Pacific by 2 to 3 degrees Celsius above normal. 2 to 3 degrees. Doesn't sound like much. The consequences are catastrophic. The 1997 to 1998 El Niño, the strongest ever recorded at that point, caused droughts in Indonesia, the Philippines, Papua New Guinea, Australia, southern Africa, and northeast Brazil. It caused floods in Peru, Ecuador, California, and East Africa. Global cereal crop losses were estimated in the hundreds of millions of metric tons. The economic damage was calculated at over $35 billion in 1998 values. Approximately 23,000 people died directly from weather events linked to that single El Niño event. Visual note: show a world map infographic with color-coded impact zones, orange-red for drought regions, blue for flood regions, all triggered by that one El Niño. Overlay a Pacific Ocean temperature anomaly chart showing the 1997 to 98 warm pool. And it gets stranger. La Niña, the opposite phase, when the trade winds strengthen and push more warm water westward than usual, can be equally destructive in different regions simultaneously. The 2010 to 2011 La Niña contributed to devastating floods in Australia, Pakistan, Colombia, and the Philippines, while causing drought in parts of Africa and the Amazon. One shift in Pacific Ocean current patterns. For continents affected at once. The ocean is not background scenery. It is the director of the show. Fact number 6. The ocean produces half of every breath you take, because ocean currents fertilize microscopic plants. Every second breath you draw in, the oxygen in your lungs right now, came from the ocean. Not from a forest. Not from a park. From tiny, single-celled organisms called phytoplankton, drifting in the sunlit surface layers of the sea. And the only reason they exist in sufficient numbers to generate that oxygen is because ocean currents drag nutrient-rich water up from the deep. This process is called upwelling. In certain locations, most famously along the coasts of Peru, California, and West Africa, deep ocean currents push cold, nutrient-dense water toward the surface. That water is loaded with nitrogen, phosphorus, and iron that have accumulated in the deep for centuries, carried there by the thermohaline conveyor belt we talked about in fact number 2. When this nutrient-rich water hits sunlight at the surface, phytoplankton explodes in population, creating what scientists call blooms, patches of ocean so dense with microscopic life that they're visible from space as vivid green swirls in satellite imagery. Visual note: show a NASA satellite imagery-style infographic with green and teal color swatches indicating phytoplankton bloom zones along upwelling coasts. Pair with a vertical ocean cross-section diagram showing nutrient arrows rising from the seafloor to the surface. Phytoplankton produce approximately 50% of all the oxygen in Earth's atmosphere. They also absorb roughly 25% of the CO2 that humanity emits every year. They are, without exaggeration, the lungs of the planet. And they depend entirely on ocean currents to bring them food. Here's the nightmare scenario that actual scientists are losing sleep over. As the ocean surface warms, it becomes lighter and less likely to mix with the cold, nutrient-rich water below. The technical term is stratification. The ocean is literally separating into layers that no longer communicate. A 2019 study in the journal Science found that ocean stratification has increased by 5.3% between 1960 and 2018. More stratification means less upwelling. Less upwelling means fewer phytoplankton. Fewer phytoplankton means less oxygen. The math is uncomfortable. Fact number 7. There is a permanent underwater waterfall in the Denmark Strait, and it dwarfs Niagara Falls by a factor of 2,000. Niagara Falls is one of the most famous waterfalls on Earth. It moves approximately 2,400 cubic meters of water per second and drops about 57 meters. Tourists come from all over the world to stand at the rail and feel small. The Denmark Strait Cataract, a waterfall hidden between Greenland and Iceland, entirely underwater, drops approximately 3,500 meters and moves 5 million cubic meters of water per second. That is more than 2,000 times the volume of Niagara Falls, and it falls nearly 62 times as far. What creates it? Cold, dense water from the Nordic seas flowing southward meets warmer, lighter Atlantic water. The dense water has no choice but to plunge downward, and it drops in a cascade that if visible would be the single most spectacular geographic feature on the planet's surface. But it sits 600 meters below the ocean surface, completely invisible, completely silent to us, and almost entirely unknown to the general public. Visual note: create a side-by-side infographic comparing Niagara Falls and the Denmark Strait Cataract using scaled diagrams. a tiny blue rectangle for Niagara against a massive blue column for the Denmark Strait. Include a cutaway cross-section of the submarine topography showing the waterfall drop path. The Denmark Strait cataract is not a geological curiosity. It is a crucial component of the thermohaline circulation. It's one of the primary mechanisms by which dense North Atlantic water dives into the deep ocean to begin its 1,000-year journey around the globe. It was first formally described by oceanographers in the 1960s, which means this staggering natural wonder, the largest waterfall on Earth by any meaningful measure, was unknown to science until living memory. What else is down there that we haven't found yet? Fact number 8. Scientists have discovered mysterious ocean current rings that can trap and preserve water for decades, like giant spinning prisons in the sea. Save the best for last. This one genuinely sounds like science fiction. When major ocean currents, like the Gulf Stream or the Kuroshio Current in the Pacific, meander and twist, they sometimes pinch off into giant rotating loops of water called mesoscale eddies or ocean rings. These circular current systems, typically 100 to 300 kilometers in diameter, spin like enormous slow-motion whirlpools, some clockwise, some counterclockwise, and they can persist as distinct, self-contained bodies of water for months or even years. But here is the fact that makes oceanographers genuinely excited and a little unsettled: the water.